Hello guys, in today's video we are going to see about complex matrix. So complex matrix means a matrix which has complex numbers. Okay, what are complex numbers again? Which are imaginary numbers. So imaginary numbers will have I in there. I along with the number like this. Like we generally write numbers as 3 or 4 or something like that. But for imaginary numbers it's 3i, 4i. So I plays an important role, and by seeing the I only we will say that particular number is imaginary number or complex number. So why we get this I? If the values are under the roots, negative values, okay, then those numbers will be written as I, imaginary numbers. Okay, now let's see conjugate of the complex matrix. So what is the conjugate means? If in a matrix, in a complex matrix, okay, if the elements in the matrix are complex in nature, and whenever we replace the complex numbers with their conjugate complex numbers, then we say it as conjugate of a complex matrix, and it is denoted by the A bar. Remember this notation. Okay, if you read this definition you might not understand, but it's very easy. Let's see example. So the simple trick is, whatever the numbers, for whichever the numbers we have I there, just make sure that for that I numbers you have to change the sign. That means here if you observe for this element it's 2 plus 3i, so we have I here in this, so it is in plus sign, so we have to write it as 2 minus 3i. So 5 is 5 because no i's are there in that. 6 minus 7i, so if you check here it will be 6 plus 7i. Minus 5 plus I, so minus 5 is a real number, so we don't have to change the sign here, and for I we have to change it. So this is the conjugate, just we have to replace the sign, that is the conjugate meaning. Okay, now if you see the note points here, note points are very important, so remember these conditions, we will be using them further in theorems and problems as well. Okay, and now one more thing, many people will get confused between the conjugate and the transpose, but they are different completely. So in transpose we will exchange, we will interchange rows and columns, right? But in conjugate we will replace the sign of only complex numbers. Okay, even for the conjugate matrix also we have the transpose, and we'll see now. Okay, now transpose conjugate of the complex matrix means, first we have to find the conjugate matrix of the complex matrix, and then we have to find the transpose for the conjugate matrix. So here we will have three matrices. So given question is complex matrix. Okay, this is for understanding, I am writing this for understanding. Given question is complex matrix, we will replace the signs. Okay, replace sign I, let's suppose for I, that is conjugate complex matrix, and for this conjugate we will find the transpose, that is transpose conjugate matrix. We will replace the columns and rows. Alright, so if the transpose of conjugate of the complex matrix is transposed conjugate of the complex matrix, okay, the definition seems a bit confusing. I'll explain the example. Remember, it is denoted by the a power theta or a degree. So like this, theta or 0, it's a degree. Okay, so then we say it as transpose conjugate of a complex matrix. We'll see the example, it will be clear for you. Okay, I'll explain you this example just normally. Okay, so you don't see, don't read this Hermitian matrix. Just for example I'm taking the same. So if you observe here, this is complex matrix given. So for this we have find the conjugate, that means we have altered the signs plus as minus, minus as plus. Then we find the transpose. That means rows will be columns, columns will be rows. So this is transpose of the matrix. This Hermitian will see the condition later. So again we have note for the transpose. So these are very important, again you have to understand, and we will be using this in the theorems, so make sure that you remember these note points again. Next, Hermitian matrix. So we, in the previous introduction video, we have seen what is symmetric matrix, right? Symmetric and skew symmetric. So here also we will have Hermitian and the skew Hermitian. So the difference is what means, in the symmetric, okay, in the symmetric we will have only the real numbers. In the Hermitian matrix we will have the complex numbers. Okay, that is the difference, first difference. And now when we say a particular matrix is Hermitian, when the transpose equal to A. So for symmetric it's A transpose equal to A, then we say it as symmetric. So for Hermitian it is A power theta equal to A. This is the condition. How we will find the A power theta? First, for the given matrix we have to find the conjugate, that is A bar. Okay, after finding the A bar we will find the A power theta. Okay, if the condition A and A power theta are same, then we say that particular matrix is Hermitian matrix. Okay, and these are note points. If you read these note points you will understand more clearly the difference between the symmetric and the Hermitian as well. Okay, now let's see skew Hermitian matrix. So skew Hermitian matrix is similar to the skew symmetric matrix. So we know that for skew symmetric, condition is A transpose equal to minus A. For skew Hermitian it's A power theta equal to minus A, right? So the process is same. The extra step we do in the Hermitian matrix is we'll find the conjugates, because we have complex numbers here, whereas in those symmetric and skew symmetric we'll have the real number matrices, so we don't find the conjugate there. Okay, the transpose is common and the condition is also common. Okay, this is what a skew Hermitian matrix, and we'll see the example here. So we have A here, we have find the conjugate, that means we have replaced the signs for the imaginary numbers, and then we have find the transpose for it, which is called as A power theta. So if A bar whole transpose, that means what? A bar is conjugate, whole transpose is A power theta. If A power theta is equal to minus A, then we say it as a skew Hermitian matrix. So if we see these note points, we will understand the difference between the skew symmetric and the skew Hermitian. So initially you might feel these four matrices definitions as a bit confusing, but they are actually very easy. So once you are able to find the difference between the matrices, then you can do all the theorems and problems, okay, with the similar procedure. Both the symmetric and Hermitian matrices will have the same procedure to solve them. Okay, theorems also same, but the extra thing is we'll find a conjugate for everything in this, that's all. And if we see unitary matrix, so when we say a particular matrix is unitary matrix, when the condition, okay, A into A power theta equal to A power theta into A equal to I. If this is the condition, then we say it as unitary matrix. So similar condition we have solved it for real matrices also. What is that? Orthogonal matrix. So orthogonal means A into A power transpose or A power transpose into A equal to I. This is orthogonal. Since these are complex matrices, we call it as unitary, and the procedure will be finding the extra conjugate, that's all. Everything is same. So always remember that whenever it is complex number, okay, whenever it is complex number matrices, complex number, we will have Hermitian, skew Hermitian and unitary. Whenever it is real number matrices, Then we say it as symmetric, skew symmetric, and orthogonal matrices. If you observe, all the conditions will be same. Okay, so this is about the introduction part, and in the next video we'll see the related theorem and the problems. Thank you.